If not Kui, somebody else. There we go. Hey guys, welcome to the second Data Engineers Lunch. That's the wrong date. Let me fix that. It should be 23rd. As I mentioned quickly just a second ago, we've been doing a Cassandra lunch for about 6 months. And well, you know, regardless of what data store you use, you eventually have to do data engineering. In fact, that's kind of our core jobs. Most of the people here, we do data stuff. So figured we start a data engineers lunch. Today's topic is common ETL frameworks. And if you have something to contribute, just put it in the chat, or you can talk about something that you've used as well. I'm actually going to be going through a list that I found, and there's some that I'm familiar with. There's some that you guys are going to be familiar with, and we'll just have a discussion about what are the common ETL frameworks that are out there across, let's say, different programming languages, because generally we're not always able to choose what programming language to use. Kui is an organizer. Kui, thanks for recording and then getting this stuff up on YouTube later. Kui also is looking for help if you want to be a co-organizer. With COVID, there really isn't much of a need for a sponsor, but we'd love to get more people to come and speak and give presentations. We're part of a data community DC, which is much bigger than this group. There's about 20,000 known unique members across the various groups. It's always growing. Data community DC, data science DC, data visualization DC, GData, Night Owls, statistical seminars, Nova Data Science, full stack data science. That's us right here, and the data education DC. What do we cover? We cover different types of data engineering. What are the roles of a data engineer in different projects, frameworks, strategies, tactics, bleeding edge, you name it. You have something just to contribute, good to get you up here to talk about it. Okay, so this is normally when if somebody's new, they'd say hi. So Dwayne, if you want to say hi again, a little bit about your background, what interests you about data, and what you hope to either learn or contribute here as a speaker.
Oh, great. My name's Dwayne Whitfield. I'm in Silver Spring, Maryland. And my background is I worked in government innovation for the past maybe 5 years. Before that, I was in the Navy. And with government innovation, I worked at the Postal Service. And I created the first NLP chatbot for the Postal Service. And I got to speak at Google Next last year in San Francisco on what I did with that.
Nice.
Right now. Yeah. Thank you. Yeah. And right now I'm really interested in just actual applied machine learning and AI. And of course, data engineers are part of that.
Cool. Very cool. Excellent. And we also have Nirmal.
Hi.
Yeah, go ahead, Nirmal.
Hey, everybody. So I'm back with Rahul and team here after a while. I was doing sort of a co-op a while ago, and there was a seed in me it was kind of growing to get back here and join hands and do some cool stuff. So that proved to be true. So just recently spoke with Danielle and Rahul. So I'm back here, looking forward to joining hands and working together, and this time with more time and more real stuff. So as a data engineer, I'm currently at Capital One, full time, doing some data engineering so I've been there about 2 years now, and half the time we spent migrating from on-prem to all cloud. So we are on all AWS at the moment. And it's just now sort of thinking, so we just lifted and sifted code, but now we're thinking how to make it more, sound, and how to make it more efficient. So it's mostly using EMR and doing ETL on a very, high level. but there's a bunch of apps, almost about 20 different pipeline and apps. So it's interesting. It's very interesting for me because I wanted to be in data engineering side. I was doing API development and working as a Java developer, a little apps here and there, but I wanted to get into cloud and big data part of it. So that's another reason I'm here. So very excited. I remember Eric's your name, and I don't know anybody else to be honest. I just remember Eric. So I'm looking forward to
Yeah.
talking to everybody.
Cool. Great. And I got another new person. Chaz, do you want to just say hi? What interests you about data? What you hope to learn here? Or if you could present on something about data engineering, what would you present on?
Hey, yeah, thanks for having me. Can you hear me? Cool.
Yep.
I'm Chaz. I work at Storyblocks, which is a stock media company we're based in Arlington. Been around since like 2012. We're probably like 35 engineers total, 5 data engineers. I started doing data engineering, I guess, 2 years ago, but mostly a full stack background. And then, yeah, I'd say that the interesting thing for me has been trying to set up a developer-friendly event pipeline that, I mean, first and foremost is easy to use because we actually had 2 previous pipelines at our company, but the process of adding like an event with the correct schema and having it like bubble all the way back to our analytics was so obtuse that, you know, it would take a day or 2 for engineers to do it, and they just weren't doing it. So I became in Avro and the Kafka Confluent ecosystem. We've had a lot of success with that. So like we put together like continuous deployment pipeline with our schemas and our events. So all it comes down to right now is a pull request, green checks, and then merge to master, and then you can like import these common libraries. So anyway, yeah, my interest recently has been like democratizing by making it, you know, really easy to use, which is, I mean, it's trite these days, but I definitely saw the pain points around, you know, developers just not using a system and us like not getting data. So anyway, that's what I could present on, but I also just want to see best practices, and I want to meet other, you know, data engineers in the local industry. So thanks for having me.
Yeah, thanks. That's a great topic, and that hits close to home. I mean, it's always the challenge of like, do we use a schema or we not use a schema? Why do we need a schema for? It's like, your APIs have a schema. What happened to that? You know, like if everything is NoSQL, then there's like no order at all, right? You have to have a schema somewhere. So, but it's got to be a balancing act, I think, right? Like you got to make it easy enough for new types of flows to come in at the same time having some like order around the chaos. So, would love to kind of hear about how you got through that.
Rob, I have one more question. Chaz, have you done things with like Docker to make your development environment setups a lot easier?
Yeah, we were pretty early adopters of Docker, like in production, which is nice because basically all of our apps or services, we've probably got like 15 or so. They're all orchestrated using Docker Compose or Kubernetes. And we were even able to make a like kind of plug and play, or what do I want to say? A development environment data pipeline that like mirrors our production data pipeline just using Docker Compose, which is nice. So by default, developers don't have the data pipeline up, but if they want to bring it up, they just check out the events repo and then run like a make. We use make files actually to kind of create like a common interface. So you just say like make up, and then it brings up the event pipeline, and then all of a sudden all the, you know, the apps are listening to it and publishing to it. So that was a key point of like making it easy to use, is like you have to have a single command to just have developers like, you know, have it up and running. And Docker is essential for that. Love Docker.
Docker and Kubernetes. Yeah, that's actually that's a good idea. I'll put that in the backlog, because there's a whole class of work now in using containers for basically data stuff. Group rules. If you have a question, just ask it. Be polite. You know, we're a small group, so you can just like interrupt me or anybody else who's speaking. Just be polite. Use it as an opportunity to ask a question or to share what you know, because we're a community. That means we communicate. Communication requires 2 people or more. So you're here, and that's of added value to everybody else here. DataStax is a sponsor. GW more so for the Data Wranglers group. They used to give us amazing event space. Unfortunately, we're not able to leverage that right now, but they've been a great partner. Data Wranglers has local sponsors, which again, Eastern Foundry was an event venue sponsor, but nobody wants to go to a real meetup these days. Nobody wants to go to a physical meetup these days. Thanks to our organizational sponsors. So Nirmal, your employer, is one of our organizational sponsors at Data Community DC. And organizational sponsors, they basically fund the 501c3 or nonprofit, which is called Data Community DC. And in case we ever need funding for pizza and beer and soda, you know, Data Community DC will come to the rescue because it's funded by these guys. Any announcements that you guys may have? Any jobs? Anybody looking for a job? Any meetups, hackathons, conferences, classes, etc.? Okay. Yeah, just as a quick kind of plug from our end, we're always looking for contract and potentially full-time data engineers. Tons of work around the Kafka, Spark, and Cassandra ecosystem, and then these days what goes underneath it, which is Docker, Ansible, Terraform, and Kubernetes with all the different clouds. A couple of upcoming events. Tomorrow, running Spark job on DataStax Astra, and then counting in DataStax Enterprise. I'm kind of curious about that next week. The Data Wranglers, we now have a weekly call on Mondays, and these are recorded. If you go to Data Community DC, you'll see other events published. They're a bit dormant, but some of us are coming back. There's a couple of panel discussions a few months ago. All right. So today, I felt like, by the way, give you guys a quick recap of last week. Last week, you guys can still see my screen. It's just like an outline, right? Yeah. So last week okay, cool. Last week we basically talked about, what does a roadmap look like for a data engineer? We talked some, core programming skills, some scripting automation skills, different types of databases, data modeling, knowledge, data processing, different types of data processing, knowledge of scheduling systems, different clouds, basic infrastructure, and then any new stuff that's coming out. And actually, this is going to be a good roadmap for us as we go through. If there are not any volunteers, either myself or I will volunteer somebody to talk about one of these topics, because I think that's what I lacked when I started on this data engineering journey, is that, people didn't tell me like, hey, you kind of have to know all of these things to be a good data engineer. Otherwise, you are at a loss, or you're going to be stuck on something. We covered also last week a bunch of different online guides, and this will be put on a blog post. And the guides are basically kind of a explanation of all of these different steps. Everybody has different sections, but most of them have generally the same idea, that you have to know a lot of different things to be a good data engineer. Some tech-specific data engineering guys out there, and then a couple of other resources that, it'll be up there soon. Today, I felt like the first thing to think about when you're a data engineer is, what are the common ETL frameworks? I started kind of outlining these a little bit. There's a backlog, and actually I'm going to put some, how to set up a event, a developer-friendly event-driven platform. Is that a pretty good kind of explanation, question, Chaz, for what you could do? Okay, cool. That's awesome. And then I think we could even put here Docker for data. I think that'd be kind of cool. So as I started going through this, and mapping out a couple of different tools that are out there, I actually found one of my kind of best sources for knowledge it's called an awesome list. And an awesome list is a movement by that was started by this Node engineer. And we have a couple of different awesome READMEs ourselves, but an awesome list is basically a README on GitHub that somebody has put together with, what they feel are some amazing resources. So for example, this is one on ETL. This is one on like pipeline frameworks and libraries. And, we curate a couple of them ourselves. But at the top level, I think in a common ETL framework, you really have to ask yourself, like, what, if you're going to go out and be the engineer today, what are the most common programming languages that you're going to face? And I think that I won't be alone if I say that, like, Java is generally at the top of the list these days because, well, first of all, big data runs on Java, or it runs on the JVM. And it may not necessarily be Java, but it could be another JVM language program that's running on there. I would say then Python is another one. Python is probably more popular, I think, in most cases because it's easy to use. It's very easy to use for beginners, and it has a lot of power if you use it with the right frameworks. So, we can talk about a few of those. And I think after Java, it would be Scala because Spark is written in Scala. Kafka is written in Scala. There's another actor framework called Akka. A lot of people use Scala with Akka as well. Now, I've been in the .NET world alongside Eric for about 20 plus years, so I know there's definitely ETL in .NET in various different languages, but C#. And recently, Node is a great framework. I love it. It's between Scala, Node, and C#, like I can do anything. I don't even need Python, but Node I think is underrepresented in ETL. There are ways to do ETL with Node, and it's a great candidate because, well, frankly, a lot of data these days is JSON, right? It's just coming in as JSON, and Node is obviously natively it's JSON. So at the top of of the framework pile with Python, I looked at a few of them before. The one that I have used personally is Spark, using SparkPy. There's another one, I think it's called Dask. And then there's another one called Ray. And I don't necessarily know if these are ETL frameworks, but these are some of I think Dask and Ray are some of the bleeding edge tools out there in Python for basically fast, clustered stuff with Python. Spark, however, is probably the more common one because everybody I shouldn't say everybody. A lot of folks who use Python, they may not know of Spark. Chaz, you mentioned Airflow. You know, I was going to say that Airflow is, I would say, is more like a
scheduler,
an overseer.
Yeah,
it's a scheduler. Yeah, totally. I'll put it in here.
well, I was just thinking some of their operators and hooks are like arguably ETL tools, you know, because it has like that plugin framework.
Yeah, exactly. Although I think some purists for Airflow would say, oh no, you shouldn't do that. You should just, you know, have Airflow run the things for you.
Right.
Definitely. In Spark, you know, we have the benefit of everything that Spark comes with. And that basically means you have access to MLlib, you have access to GraphX, you have access to all the Python libraries, right? That may or may not be parallelized. But Spark is a general data compute parallelized framework. It's the next generation after MapReduce. Dask and Ray is too new for me to comment on, but Ray it's one of those, you know, things that came out of Berkeley Labs, and you know, Berkeley Labs is where Spark came out of. So anything that comes out of Berkeley Labs, you want to take a look at it. You know, what does this do for me? I think it's fascinating. Basically, it's like the actor framework in Python to build these kind of like massively scalable, massively parallelized applications. And what that means is that you don't necessarily have to use something like Ray for ETL. It's just, it could be used for ETL. Same thing with Spark. You know, you don't have to use Spark for ETL. You can use Spark for just machine learning. But it's about doing a very, very large scale operation. The other one I mentioned is Dask. I think Dask is, you know, that's Dask on Ray. Dask has been around a little bit longer than Ray, and Dask can run on top of Ray, but I think Dask is more of like a core analytics engine, which then you can use for doing data engineering, doing data processing. And what it does is it essentially takes your, you know, your NumPy or your Pandas, and basically expands that world to be able to do much larger operations on it. So if you have fun with NumPy or you have fun with Pandas, you can do large scale operations with Python with these tools. These are the ones that that come out at me. And then Airflow is actually Chaz. Do you guys use Airflow?
Yes, we do.
Do you want to give it? I'll just bring it up on the screen. Do you want to give a quick like minute, 2
minute
explanation of what?
Yeah, I mean, it's basically just a DAG tool, so directed acyclic graph. And my mental model of it is like most ETL processes, even the most complicated ones, can be boiled down to just a series of tasks with an exit code of 1 or 0. And some can be run in parallel, some depend on others. And Airflow just lets you do that, lets you just like arrange a series of tasks, and then gives you green dots if they pass and red dots if they don't pass. I view it as like a, you know, Jenkins, but with extra stuff involved.
Yeah, I would say, and you know what, people actually use Jenkins for ETL stuff too, for running jobs, you know, in sequences. But yeah, totally. And actually wanted to show, you know, what a DAG is for some of the newer folks. A DAG, a directed acyclic graph, means that there's no loops in the graph, meaning it has a start and it has an end, and there's dependencies to it. And in Spark, there's also a DAG, essentially, that gets computed. When you write code, it gets computed into a DAG, and then it's broken apart and given to the different workers. It's just the important thing, if you're not aware of graph theory, that's what a DAG is. When you see it, just think about it as a tree of work, but it's not really a tree, it's a graph. And what Airflow is doing is essentially managing all of those dependencies of what needs to happen first versus what needs to happen next in this framework, and it can execute these things, wait for it to be done before it spawns the next thing to be done after that. Yeah, Airflow is definitely really cool. Anybody else, anything else that you guys can think of on the Python world from a pure data processing or data engineering perspective? Okay. And, just to take a look at our reference here, there are, let's see who else is in this world. Yeah, so Celery is, it's a task runner, basically. I know about Celery because the Redash project, which is an open source BI tool, it uses Celery. So when you have a query in Redash, it uses Celery to set up the task, and then Celery goes and gets all the data and puts it in cache. Then you can see it in your BI tool. Pretty straightforward to use. So I would say it's a lot less complicated than like Spark if you really wanted to get into it. And I don't know if I would say this is an ETL tool, but SQL Alchemy is a part of Python as a library, which allows you to get data and work with data much easier. And SQL Alchemy has a lot of different connectors to different databases. So there'll be like a database connector for Postgres, for MySQL, for SQL Server, for Oracle, or even I think for Cassandra, there may be a different one. But anything you might think of in terms of a library to connect to data, I would put that in a different world versus something that executes tasks for you. That's like Mr. Job would be another one, right? MapReduce jobs in Python, for example. There's one more that I'm not seeing. Yeah, go ahead.
Anybody been using PsychoPG for connecting to the SQL from Python? I started using it just recently. It's just like a library.
How do you spell it?
Combination of another project. And so there was a project called Psych, PSY, something.
Okay.
They combined with the Postgres. So they turned it into a library to, connect to Postgres from Python.
Got it. Oh, okay, cool.
Yep, PsychoPG2. So it actually claims all security vulnerabilities like, SQL injection, all of that. It has a really awesome solution. So just recently I've started to see a lot of people using it. I myself have been using it for a while now.
Cool, very cool. And the other thing which you can consider is, and I think maybe that's a different topic altogether, is leveraging Python in a serverless environment to do ETL, and there's a framework called Serverless, but Serverless essentially takes your code and puts it to, let's say, AWS Lambda, or Azure functions, and I think that we can cover this. Serverless functions really applies to any language, but maybe I'll just put that up here. I think that's the next generation. As things went from massive computers to virtual machines to containers, now there's serverless, meaning you write code that somebody else is executing for you. I think there's a lot of work involved to make sure that this happens to run flawlessly and it does everything properly. But at the end of the day, why bother running computers and servers if somebody else can do it for you? So I think that would be a good topic to cover in the future. Java is probably, you could do the trend analysis on Google Trends to see which one is more popular between Python and Java. But I think when you're at a particular data size eventually you're ending up using something in Java. So you mentioned USPS, Dwayne. I actually worked on a project at the USPS where we were doing like 15 terabytes of data input every day at that time, and I think it's now up to 15 terabytes, so 150 terabytes of data input every day on a Kafka, Spark, Cassandra type setup, and we were using a lot of different things. We were using Spark streaming, we were using MapReduce, we were using Spring Batch, Spring Data, and if we wanted to use anything else, we'd have to ask the question, will it run faster than Java? And most of the time, unless it's Scala or Java, maybe .NET will run faster on certain cases, but Python and Node were kind of out of the question, and we didn't have the skill wherewithal to basically write C libraries. That's really the only way to make it faster, is to write the libraries in C, put them into Python. Even Node can have C or C++ libraries, but Java pretty much rules the world in my opinion, I think, in terms of data, because when, Doug Cutting from Yahoo, who, inventor of Lucene and inventor of Hadoop, when he went out to create Hadoop, he wrote it in Java, and that has stuck. Even the initial version of Lucene was in Java and still is. That's where the whole, the world of big data came from Java. So I think that's why it's stuck, not in good or bad ways, just it is what it is. I prefer Scala to Java, but Java is everywhere. Couple of useful things. So MapReduce, now there's MapReduce 2. Just as a high level, I think MapReduce can be a foundational learning tool to understand how to manage very, very, very large sets of work. But essentially, MapReduce is made up of two ways of solving a big problem. First is you map, meaning what is the work, right? And then you do reduction, which is, taking this work, how do I take these things that's mapped out and break it into smaller things, and that's what the mapping is. But reduction goes smaller and smaller and smaller until you get a result, the work itself. And using this simple pattern, big things were built on top of a very big file system. So people came up with things like Hive or HBase or Pig. And what these things were doing was taking the file system where the stuff is stored and translating it into MapReduce that would then get the data, do all these operations, and then give us the result back. Then came Spark, not necessarily in Java, but there's a lot of people in the Java world, in the Spark world, that use Java, just because the talent is out there, people are out there. And Spark allows people to do everything that Spark can do, which is what I mentioned earlier, MLlib. It allows you to do GraphX. You have structured streaming now. But, at the end of the day, Spark itself is just doing a bunch of map reductions. It can do more now, but that's where it started off with. It was just a better way to do MapReduce. The benefit, the difference, I would say, the benefit will come later. The difference is MapReduce retrieves and stores data back to disk all the time. Whereas in Spark, it's bringing it into memory, does all the operations into memory, and then saves it to wherever you want it to save it, right? But then there's other things in there that are really cool, which is data frames, where we can say, load X into this data frame, and you can operate on the data frame, and then you can save it back. And the data frame operations are similar to what you have in Python, but like you can do SQL queries on these data frames. You can do joins on these data frames. You can do joins across data frames. And that's where Spark SQL is kind of a heavy hitter in that any data that you bring into Spark and you put it into a data frame, you can do SQL commands on it. You can do SQL operations on it. You could do similar things in MapReduce before using Hive. Well, Spark SQL is basically Hive compliant. And all Hive is, it's a subset of SQL, right? So imagine in one toolkit being able to connect to a billion different things, bring them into data frames where they're kind of sitting in memory, persisted to whatever storage it's coming from, whether it's coming from JSON, Parquet, or Cassandra. I mean, you name it, you could connect a data frame to basically anything. And while those data frames are sitting in memory, you could be doing graph operations, you could be doing machine learning operations, you could do streaming operations on it. And at the same time, you could connect a BI tool to get there. I mean, Spark is words can't describe it. It basically does everything. And you can do all of that in one framework. Why wouldn't you? In fact, I'm working on more than a few client engagements where Spark is the data platform. It is the data and analytics platform. And there's other tooling that we're using, including Jenkins in one case. In another case, they've made their own ETL framework in Java to run on Spark to make it easier for people to get data in and get data out. But Spark is an all-purpose thing. You can have jobs, batch jobs to get data into your data store. At the same time, you can use something called Livvy, Apache Livvy, which will basically allow you to use Jupyter Hub to talk to Spark to run those operations in Python. I think even in Scala as well. I may even put Spark in its own category. I mean, really, it's like Spark can do Java, Scala, Python, R. Can I do something else? I don't know. I don't think it can do anything else in terms of language. I think it's kind of like that's it. But still, that's a lot. The other two contenders, actually, I forgot another one, Camel, Apache Camel, a good one. And Apache Camel is now becoming modern. It can run on Corkus, which is a very fast, version of Java. But Camel also has not only ETL, but it also has now stream processing. And I think Camel is one of the original granddaddies of ETL on Java well before Spark. Anybody use Camel or the new Camel? It's like an oldie but a goodie. Yeah, various ways to get data in, data out. The big thing about Camel is connectors. There's even a Kafka connector for Camel now, and you can run it on Spring Boot. What else do you need? And let's see.
Camel's used more like a service bus where different applications can exchange data to each other, send data to each other. But that was about like 7-6 years ago. After that, I haven't seen anything. So you're saying it's used in ETL type of domain now?
It started in ETL. That's what Camel started in. Its initial purpose was source and sync, right? Basically, how do I get data from here, put it into here? And that was the main goal of Camel at the very, very beginning. And then over time, they started to add more what you're talking about. But basically what you would do is you'd say, for example, right? Take this data, do this, right? Save it somewhere else. That's ETL, right? This is what it's doing. But Camel's roots are ETL. That was one of the first reasons why people were using it. Well before, let me see what the first Camel. If I just look for Apache Camel 1.0 release notes. Let's see. Where is the feature list? Yeah, they've updated their website and stuff. It looks so different now. Here we go. Yeah, even this was like way a little bit more advanced, but yeah, we would use it just to set up these pipelines between systems, and the pipelines did not necessarily have to be kind of like based on streams. You could just use data to data basically. But it's a good point. Actually, I would not have brought this up to show like what else it can do, but yeah, it's a very powerful tool. The other, by the way, there's so many in Java. I mean, there's so many in Java. In just the Apache project alone, there's so many. But Spring Batch and Spring Data are the ones that I think anybody can get started with, meaning you don't have to have anything special. You can embed Spring Data or Spring Batch into just you pull down your code, you run it locally, and anything that's built with Spring, the beauty is that it's using inversion of control, so you can like use different libraries whenever you want to connect to Solar, to connect to JDBC, any JDBC. But then Spring has all of these other things there that help you do, for example, Kafka integration or AMQP. There's even something called Spring Cloud and Spring Data Flow. Spring is more common than one would imagine. It's everywhere. Spring is not just used for microservices like Spring Boot, excuse me. Spring is used for like everything under the sun. In fact, I think if you're a Java developer and you don't know Spring, you're at a loss because you're not using so many cool features that are available to you. There is a cool project called JHipster, which is not exactly data engineering stuff, but I wanted to show this to you. So based on Spring, JHipster allows you to define a schema, and it basically creates a full-fledged application for you, including the API, including the single-page application to talk to it, the data layer, and the schema. And why would I mention this to you? If you need a quick and dirty front end to some sort of data source where you're bringing in data, you just want to view it, this would be actually a pretty cool program to look into. Anyways, back to what we're talking about. Yeah, JHipster is pretty cool. Any other Java frameworks, tools that you guys have used that make sense to still use today?
You mentioned Corkus. Isn't that supposed to be like a Spring-ish thing? I don't actually know anything about it.
So Corkus is actually a execution engine for Java, right? It's basically a faster Java. So it has these bindings that you use, and it will run your code in a smaller JVM, and it runs faster. So and it's native, right? So here we go. This is what I think gets people right. So Corkus plus native via Graal VM is the actual VM that it runs on. It's a 12 megabyte, kind of footprint versus if you're looking at Corkus just on the JVM via OpenJDK, that's 73 megs, versus if you make a container with all of your stuff on it, right? That's 136 megs. So it's just smaller. Even without the Graal VM, it's just smaller and faster. here's where it kills it, right? Running a JVM program, initially it has to JIT, just-in-time compile. On a big cloud native, meaning on a Docker container, you're talking about getting the container up and running, getting all this, you know, everything, the Linux services running. Then you run Java, it JIT, it takes a couple of seconds to start. Well, if you're running it on Corkus, on the Graal VM, it's like that, right? And you could take Corkus, compiled stuff, and put it in a serverless or any container world, and it'll still be faster than everything else out there. Yeah, the reason I know about Corkus is because I was checking up on Camel. And then I looked further. There's a bunch of like quick starts, but it's really useful in making it like a reactive framework that's super fast, super scalable. Let's see. Commonly, you'll see it, you know, associated with Kubernetes. Here we go. Yeah, it's worth a look if you're squeezing out that, you know, 80% of the processing power and time. So just mind you that it's like, it doesn't work with everything. It doesn't work with every Java program. It works with some of them that people have kind of tried it out on. And it's, so like you can use it with Vertex, which is one that I'm aware of, but I'm not really familiar with. Hibernate, everybody knows Hibernate. And, you know, it's just about making Java run faster. And there's a couple of things that you do differently, but it's Java. That's a Corkus app for REST API. You know what? I'll put that in the backlog. Somebody can do a deep dive on Corkus for data. It'll be interesting. Cool. Scala, we kind of covered with Spark. There is a system, I think it's called Scaldi. Not Scalding, but Scaldi. No, that's not what I was looking at. That's for dependency injection, sorry. And let's see. Yeah. I think I'm just looking for something else. Data flow, you know, I don't think it's that popular, but, you know, it's just based on Spark. Honestly, you know, if you're going to use something else other than Spark, you have to ask yourself, like, who's maintaining it? Who's going to, you know, give me something bigger, faster, cheaper? And, you know, this is not one of those tools, but it's just good to see, like, what do they do on top of Spark? What do they do differently? And I don't think this one in particular happens to offer anything. Yeah, I'm trying to look for something else. There's another Scala ETL framework. It looked similar to Scaldi, and I'm just like not finding it. I'll come up with it in the next few minutes. If I don't, I'll put it on the blog post. Yeah. Nope, not able to find it immediately. We'll come back to it. .NET, it's similar to the Java world. There is some Spring.NET, but you know, in recent times, there's actually .NET on Spark. It's called Mobius, and it's actually maintained pretty well by Microsoft, which is C# and F# bindings for Spark. So it takes your code, puts it on the Spark engine, executes it, and it's like, yeah. So there's actually Mobius is now deprecated. Now it's just .NET for Spark. There you go. .NET for Apache Spark. Data processing. It has Spark streaming. It has, you know, basically everything that Spark has. It just adds .NET for it. Right. That's it. Hey, Eric, do you remember anything else for ETL for .NET? There's definitely Spring .NET for some things. You have Spark. Yeah, so many things have come and gone in the .NET world. Data-wise, I think people will use SSIS, SQL Server Integration Services, to get data in and out sometimes. Okay. And finally, Node. Actually, a colleague of mine wrote this up. Node ETL framework, which, if you've not done, ETL in Node, I'm just a fan of JavaScript, and I'm a fan of NodeJS, so it's kind of like pay attention to it. But we have a couple of projects where we're doing data scraping, data mining, and Node.js has beautiful packages for grabbing data from web pages. Python does too, but with Node.js, like Casper.js, for example, it's an invisible browser. You can run processes to get data from systems that don't have an API. Yeah, so this is what this I think really we're just talking about is using the body parser library. There's a lot of libraries in Node which are just about getting data, JSON or HTML, and processing it. Well, I didn't mention here. More specifically, imagine looking at HTML data and needing to process it, and that HTML data is changing in an invisible browser. I wouldn't know of anything else other to use other than Node.js, and to use those libraries. And just kind of the benefits of Node for ETL, it's asynchronous, so you can write processes that just run independently, and you could consider putting this in serverless functions. Works with JSON natively, so if you're doing ETL from JSON into JSON, and you don't need to do a lot of crunching, you just need to do like a little bit of filtration, a little bit of manipulation in JSON. It's worth looking into, and you're not stuck with using just npm to do stuff for you. You can also use I think it's called PM2, and PM2 basically runs long-running processes for Node. The other thing to consider, when thinking about Node for ETL is you can use Node for the edges, right? Get data in, and you can use Node to get data out, like an API. But you probably won't use Node for your actual, crunching, right? You can use Java, you can use Python for that. But I guess what I'm trying to say is that you don't have to use one language for everything, because each of these has their benefits. In fact, in a perfect world, which I quote unquote seen at clients, they use everything. They use whatever does the job well. Python has a lot of great machine learning libraries, data science libraries. They use that for certain aspects of the process. Spark at the core does massive amounts of data processing at scale. So what people will do sometimes is they will prototype the data process in Python, in Jupyter, and then they will operationalize it in Spark. There's some work involved, but that's definitely doable. And if it's still not fast enough, they may consider putting it into pure Scala or Java. But for the most part, it actually works out.
I mean, so do they, I had a question for you. So do they like reduce the size of the data set when they do it in Jupyter to see if it makes sense, or how do they do that?
You can actually, you don't have to. You can actually use Jupyter with it. Oh, actually, I mentioned it. I didn't bring it up, but it's called Apache Livvy, and it wraps Spark with the REST API, and then Jupyter can talk to it via that API. So this is just one, so this is what Livvy does, right? So then you use Jupyter, I think it's called Spark Magic. Yeah. And so Spark Magic then connects Livvy with Jupyter. And so anything you could do in Jupyter, you can then now run on a massive cluster. So they can use Jupyter to do like, this is basically Hive, but if you're using Spark SQL, right, you would be doing it against a tool there. Here's your program this is a Spark program right here. Does that answer your question?
Yeah, thanks. I appreciate it.
Yeah, it's actually I only learned I knew about Livvy for REST APIs, but I only learned about Spark Magic this summer, and it blew my mind. Like, oh, wow. So even Jupyter Hub has an idea of like a spawner and a scheduler to do certain operations. Like you can scale Jupyter Hub. Jupyter itself is different than Jupyter Hub, right? So Jupyter Hub is like a cloud thing. And you can run Jupyter Hub on Kubernetes, and you can do a lot of tasks using Jupyter Hub. But when you run Jupyter Hub with Spark via Livvy and Spark Magic, then you're giving the developer or a data scientist or a data analyst really one environment to prototype things, try out big scale things, and then once it works, you make that into a Spark job and you put it into production. Yeah, it's cool. It's cool. Yeah, actually thinking about it, maybe we do one on that too. For Hub. Cool. All right, guys, we're at the top of the hour. It is 1 p.m. I want to respect your time. Plenty of great ideas to talk about just from this discussion. If you want to present, and I think Chaz, you and Dwayne, if you guys want to present something, we have a couple of these other guys lined up for the next few weeks, but and Nirmal, this is a great way to put yourself out there because we're going to record it and pimp you out on YouTube in a good way. So if there's something that you guys want to present on, shoot Akwi an email. Where is the chat? Kui, can you put your email in there in the chat? Because I lost my, there we go. There it is. Yeah, Akwi@Anant.us. And yeah, next week, if you guys are ready, we'll put you front and center. Love to talk about data next week, same time, same place. Looking forward to seeing you guys. Have a happy Thanksgiving, and see you guys next week.
Sure. Nice talking to you, everybody.
Thanks. Nice meeting you. See ya.
Peace out, guys.